Here are just a few examples from my math lab R5. I'll do number 11, 29, and 33. These may look different on yours, like they might have different numbers, just because it kind of randomizes the numbers, but it should be the same style and you should be able to solve it the same way that I am solving it. So number 11 is actually what we call a perfect square trinomial. And so what that means is it follows the pattern A plus B quantity squared equals A squared plus 2 times A times B plus B squared. So if you want to solve it as a perfect square trinomial, that's okay. That's perfectly fine. You just need to find out what A and B are. If they are both perfect squares and it matches that your middle term is 2 times A times B, then that is a quick way to find your two factors, your two binomial factors. So in this case, a squared is x squared, so we know that a is just going to be the letter x, because if we take that 2 away, a equals x. B is going to be the square root of 16. The square root of 16 is 4, so that means x plus 4 squared equals x squared plus 2 times x times 4 plus 4 squared follows this pattern. So I found out that x is a because a squared is x squared. I know that b is 4 because b squared is 16. So the square root of 16 is 4, the square root of x squared is x. And then following that pattern, I'm going to put a here and b here and square it and say that a squared becomes x squared, 2ab becomes 8x, right? And then b squared becomes 16. So that is the way to do it if you can see that this is a perfect square and this is a perfect square. You can follow this equation pattern, but you do not have to. You can also just say this is a normal trinomial, x squared plus 8x plus 16. And instead of a and b, I have a, b, c. So the difference is this only has two terms, so we put everything in terms of the two terms. But here it's a trinomial, so we have the three terms. And I know this is a trinomial, but this is a trinomial that relates to this one. So we put this all in terms of the binomial it becomes. And remember, our rule for factoring a trinomial is that so we'll have two binomials, and these two terms are decided by any term that multiplies to equal c and two terms that add to equal b. Sorry, I almost wrote 8. All right. So our c is 16, so we need to multiply to equal 16, and we need to add to equal 8, right? And I just make a list. So the factors of 16, I have 1 and 16. The 8 is positive, so I'm only going to stick with positive numbers. I have 2 and 8. I'm just going down the list. 1, 2, 3 is not a factor of 16. 4 and 4, right? 5 is not a factor of 16. 6, no. 7, no. And then we're back to 8. So we've come all the way around. 1, 2, 4, 8, and 16. Now, which of these add to 8? 1 and 16 is not 8. 8 plus 2 is not 8, but 4 plus 4 is 8. So what I do is, because the a is 1, there's no number in front of the x, I can just say that this is x times x, right? And then I have a positive 4 and a positive 4. So x plus 4, which becomes x plus 4 squared. Good. And you can go back and check it. X plus 4 times x plus 4. X times x is x squared. X times 4 is 4x. The next one's also 4x, and then 16. These two become 8x. So you can see that you got back your original trinomial, so you know that that is a good answer. Number 29 is 3z squared plus 4z plus 1. So now we've gotten much more difficult because the a, so we're still in that format, ax squared plus bx plus c. The a is not 1 anymore. It doesn't matter that the z is not an x, but the a is not 1 anymore. So az squared plus bz plus c. A is 3, B is 4, C is 1, right? They're all positive. Now, because A is not 1, it doesn't multiply to equal C. Now I need to find two numbers that multiply to equal A times C. So when I am factoring, it needs to multiply to equal A times C, and it needs to add to equal B, which was true up here. It's just that C times A is always going to be C times 1, right? If the A is always 1, I just left out the A to make it less confusing. But then it makes it a bit more confusing here when we suddenly introduce A, right? So it's always C times A. It's just easy because A is 1. So we need to find two terms that multiply to equal A times C and add to equal B. So it'll multiply to equal 3 times 1. It'll add to equal 4. 3 times 1 is 3, right? So it's either 3 and 1 or -3, -1, right? Which one of those adds up to 4? Only these. When you have the first term not a 1, you cannot, so here we found it was 4 and 4, so we just said x plus 4, right? You can always do that if A is 1. When A is not 1, we cannot say that, because imagine if we said that. Imagine if I said 3z, sorry. Imagine if I said 3z squared plus 4z plus 1 becomes z plus 3, z plus 1. First, my first term, z times z is just going to be z squared. That does not match 3z squared, okay? That is our problem. So we do not do that if the first term has any number in front of the letter. Instead, we take the b and we replace it with these two. So we had, I just want to be super clear here, we had 3z squared plus 4z plus 1. We found two numbers that multiply to equal 3 times 1 and that add to equal 4. I take those two numbers, I add the variable to each one, so positive 4z becomes 3z plus 1z, okay? And I replace the 4z with them. That's all I can do with those two factors I found. Now I'm going to cover up, or sorry, I'm going to look at it, 3z squared plus 3z plus z plus 1. This is now going to require factoring by grouping. So it doesn't matter if I put 3z first or the z first. I'm going to cover up my last two, my second group, and I'm going to say 3z squared plus 3z. I can factor out a 3z, right? So 3z squared divided by 3z is just z. And then 3z divided by 3z is just a positive 1. So that's my first half of factoring by grouping. Now I have a plus z plus 1. It's a positive, so I need to bring down that plus. Z and 1, there are no common factors, so I'm actually just going to take out a 1, which I know sounds like a bit of a cop-out, but you'll see that z divided by 1 is still z, 1 divided by 1 is still 1. It will work out because, oh, I put it too high. Dividing by 1, dividing by 1. It'll work out because you still have z plus 1. So let me rewrite that. That is 3z times z plus 1 plus 1 times z plus 1, okay? Even though I could only factor out a 1 here, I did factor out a 3z here. My common factors is the binomial z plus 1, so I'm going to take that out, z plus 1, and it is being multiplied by both of those, so 3z and 1. So those are my two factors now. Not the 3z and the z, it becomes z plus 1 and 3z plus 1 as my final answer. You can check it, 3z plus 1 times z plus 1. 3z times z is 3z squared. 3z, z, 1. 3z squared plus 4z plus 1. So that goes back to the one we had. So that one's okay. And finally, number 33 is written all sideways. Number 33 is 5x squared plus 18x minus 8. As you practice with these, you can start just guessing like, okay, if it's a 3z squared, I know one of them has to be a 3z and the other has to be a z. If this is a 1, I know they both have to be 1s. And so you could figure that out very quickly by just thinking what are the factors of 3 and what are the factors of 1. But this is the most consistent way to do it. As you practice, you will get much faster. So now I have I guess we'll say plus C. All right, I know A is 5, B is 18, and C is a -8. All right, I need my middle terms to multiply to equal A times C, and I need them to add to equal B, right? A times C is 5 times -8, which is -40, and B is 18. So this might be kind of a long list of factors of 40 that -40 that add to 18. So I want two numbers that are pretty far apart, right? Because I want to subtract them and get the number 18. So it could be 40 and 1. It's a positive 18, so I'm going to make my smaller number the negative. It could be 20 and -2, right? It could be 10 and -4. It could be 8 and -5, and so on. I think that might be it. So of these, 40 minus 1 is not 18. 20 minus 2 is 18. So here are my factors that work for 5x squared plus 18x minus 8. Okay? That means I go back to 5x squared plus 18x minus 8. I take that positive 18x and it becomes 20x minus 2x. Okay, it's a positive 20x and a negative 2x. And I replace the 18 with that and leave everything else the same. Again, it doesn't matter if the 20 is here, you could put the -2 here. It will still work out the same as you factor by grouping. 5x squared, 20x minus 2x, and -8. They don't have any factors in common, so we're going to factor by grouping. 5x squared plus 20x, I can divide them both by 5x, right? That means I take out the 5x. 5x squared divided by 5x is just x. And then 20 divided by 5x, or sorry, 20x divided by 5x is 4. Is that all right? Now I look at my second group. Make sure, because this is a minus, that I'm going to make my make this first term a negative. All right. So -2x and -8, I can take out a -2. right? It must be a negative number for this to work out. So that's negative 2. Negative 2x divided by negative 2 is just x. Negative 8 divided by negative 2 is 4. So hopefully you got x plus 4 as the common binomial, okay? That means I take out the x plus 4 and I multiply it with 5x minus 2. Again, you see 5x squared and you can think the only factors of 5x squared are 5x and x. The only factors of negative 8 are 4 and negative 2 or negative 4 and positive 2. So you could just kind of switch those numbers around until you get what you want. But you can also always check it, and you can always do it this way, the long and safe way. X times 5x is 5x squared. X times negative 2 is negative 2x. 4 times 5x is 20x. And then 4 times negative 2 is negative 8. So that is 5x squared plus 18x minus 8. So that works out. So those are 3 examples from my math lab for R5.